I've just been looking at your Class 10 syllabus in physics. Here's the syllabus book. And I see that an important part of your Class 10 physics syllabus talks all about energy. Here we are, work, power and energy. And I'm actually sitting now in the Bank of Bhutan. So why, you may ask, am I sitting in the Bank of Bhutan to talk about energy? Well, let me explain. Energy is quite a difficult idea. You can't see energy. You can't feel energy. Energy is an idea. It's a concept. But it's all around us all the time. So I come back to the question, why am I sitting in the Bank of Bhutan and talking about energy? Well, what I want to explain to you is that energy is rather like money. You need money to do things, and you need energy to do things. So think of energy as like money. And here I'm in the Bank of Bhutan because in here there's lots of money. And in the suitcase just beside me, if I open it, you will see a great pile of money. Energy. With this money, I can do all sorts of things. There's a lot of money in here. Piles of Ngultrums. And I wonder what I could do with all of this money. I could buy a car. I could buy a bar of chocolate. I could build an apartment block. I could pay to run a hospital. There are all sorts of things that I can do with money, just as there are all sorts of things that I can do with energy. So I've got a great pile of money here. Think of it as if I had a great pile of energy. Energy allows me to do things. We talk all the time about I haven't got any energy, I'm tired. Or I'm feeling very energetic today. Or to walk up to the top of the mountain requires a lot of energy. So also, I want to buy myself a car. I need money to do it. So energy and money are very similar. And in your syllabus, it talks about different types of energy. So how does this, different types of energy, how does it compare with money? Different types of energy. Kinetic energy, potential energy, electrical energy, chemical energy, a whole lot of different types of energy. Just as with money, I can have different types of money. United States dollars is one type of money. Singapore dollars, another type of money. 200 euros, another type of money. From Australia, Australian dollars, another type of money. And Canadian dollars, 1,000 Japanese yen, another type of money. 1,000 Singapore dollars. So, all these different types of money are just like the different types of energy. Instead of Singapore dollars, Canadian dollars, euros, Ngultrums, and here's a nice little 1,000 Ngultrum note. Instead of different types of money, I can talk about the different types of energy.
Kinetic,
Gravitational potential.
Chemical,
electrical,
heat,
Elastic.
sound,
and light.
very important point is this. I can change one type of money into another type of money. If I have a 1,000 Ngultrums and I'm going to India, I will need to change that into Indian rupees, changing Ngultrums into rupees. If I'm going to Singapore, I'll need to change my Ngultrums into Singapore dollars. So one big job of the Bank of Bhutan is to change money from one type of money into another type of money. And so it is with energy. We can change one type of energy into another type of energy. We can turn chemical energy into kinetic energy. We can turn kinetic energy into electrical energy. So if ever you're confused about what is energy and about the different types of energy, remember, energy is like money. Money comes in different types. They're called different currencies. So energy also comes in different types, and I can change one type of energy into another type of energy, just as I can change one currency into another currency. And in this and in the following program, I'll talk a little bit more about the different types of energy and about how we can convert one form of energy into another form of energy.
당같이 다르게 덴신디 에너지기 콜레메 송하나 배워진 니슈 개구 셀럽슬리비 딜루를 민기 남당 람포마도 레셔이비 딜레 같이 개구디 라 같이라 비로 고비 배워진 하나 기대지 야 투고를 키고고 딜레 추위 덤지지 야 투고를 키고고 데 또지사로 키고고 데 키고메 받진 라 그냥 비미츠 데 배워진 청하날에 춤진요 걸리나주님의 그 개구매 와진 때 개도구 마음이죠. 때 니즘에 때 개구를 한번 마루래 해시비 때 배워진 띠루즘질을 자셔봐진 띠루를 한번 마루래 해시 같이 두비기 띠루로 차이나기 띠루로 US기 띠루로 뱅콕기 띠루로 싱가포르기 띠루로 띠루를 한번 마루래 해시비 때 띠루디 같이 띠루다 슉세디 가데베 찌가 마치기 되어서 되어 예모서 와진 띠루디 찌기찌 같이 소도 마치 배워진 같이 두미 마 자갈로 주니 배워진 같이 두기 띠루 마 자갈로 주메도 니즘에 디조답루 같이 자가 두비 띠루디 자갈로 쓰고 니즘에 같이 슉셀로 기구로 안 됐어야 한 번만도 레셔 입이나래 찌기찌기 소소이 저도 라베오다 배워진 라 같이 찌기찌 저가 롱배 같이 인기나 배우신 조깅슬라모와 때 주의주의주죠 안을로 키고 안하죠 둘로 안을로 주의주의조다 키고 진날에 지 소이 조다 같이 인기나 배우신 지인적 에너지라모와 때 kinetic energy로 potential energy로 chemical energy로 그래서 안에 소이 조다로 같이 슉세디 띠루기 녹삼 땅에 랑렌 타바진 하고알로
So now I'm going to talk a little bit about each of the different types of energy. And I'm first of all going to talk a little bit about kinetic energy. And we've come down to the Luga Cinema Hall because if we think of the word kinetic energy, how did that name come? Well, it comes from the Greek word kainos, meaning movement. And we're here outside the cinema because when movies first started, the place you went to see them was called a kinema. Just like in kinetic energy, it was called a kinema. And then over the last several decades, the name has gradually changed to cinema. So you could think of this as the Luga Kinema, where we come to see movies, and kinetic energy is movement energy, energy of movement. And we've got so many examples all around us of things moving, possessing this type of energy called kinetic energy. Remember, from the Greek word kainos, kinema, cinema, kinetic energy, a cinema where you go to see movies. So as we sit here in the nice sunny morning here on Norsim Lam, we're surrounded by examples of kinetic energy. Cars moving, people moving, motorcycles moving, all around us, kinetic energy, energy of movement. And you'll remember that there's a formula for kinetic energy. Kinetic energy, you can measure it. And the way to measure it is with a formula which says the kinetic energy equals a half times the mass of the object times v squared, the square of the velocity. Kinetic energy equals a half mv squared. Now this is very important. So if I double the velocity of a vehicle, I increase the energy 4 times. So if I go at 20 miles an hour and then go at 40 miles an hour, I've actually got 4 times more energy. And that's important when it comes to stopping, because if I'm going twice as fast, I need 4 times more energy to make me stop. And if I go at 60 miles an hour instead of 20 miles an hour, 3 times faster, I need 9 times, 3 squared. I need 9 times more energy. So as something goes quicker and quicker, the amount of kinetic energy that it's got increases very rapidly. So our formula, kinetic energy equals a half times the mass times the square of the velocity, is very important. So we've seen cars moving, we've seen trucks moving with their kinetic energy, we've seen water moving in a river. The water has got kinetic energy. And even the air moves too. When the air moves, we can feel it, we call it wind, and the air has got kinetic energy. And the air can transfer some of its energy to prayer flags, which move in the wind. So you see, kinetic energy is all around us. Now, one type of energy is gravitational potential energy. And everybody in Bhutan should be familiar with that, because gravitational potential energy is what you've got if you're high up, and lots of places in Bhutan are high up. And if we look behind me there onto the top of the hills and mountains, the higher up you go, the more gravitational potential energy you've got. And you actually have to use energy to get this gravitational potential energy. So you have to use energy to walk up to the top of the mountain. And you know you have to use energy because at the end, when you get up to the top, you're tired. Well, actually, we're here in Sherry Square, which is a new shopping complex. And they've got a way here of you getting gravitational potential energy without you having to use any energy. Let's go in and have a look at Bhutan's first moving staircase or escalator. So here we are in front of Bhutan's first escalator, and it's a way of you getting gravitational potential energy without you having to do much work yourself. It's all run by electricity, and you get more gravitational potential energy because you're rising up. So these children are going to get on this escalator. They're not having to exhaust themselves climbing upstairs. The escalator takes them upwards and upwards, giving them more gravitational potential energy. Yes, and so here they are now, losing gravitational potential energy. They're coming down. And here's another way of gaining gravitational potential energy without you having to do much about it. Very easy way. A lift. And as you'll see, some children going up soon, gaining a lot of gravitational potential energy without having to use all that energy they'd need to climb up dozens and dozens of stairs. So a lift, it actually converts electrical energy into gravitational potential energy. Another very important form of energy that you have to know about is chemical energy. And as the name says, chemical energy comes from chemicals. You get chemical energy when two chemicals react with each other. And sometimes when they react, you get other forms of energy coming out, heat, light, and even motion. Now, a very good example of where we find chemical energy is here in a firework. When I ignite the firework, you'll see the chemicals all react. But before we do that, let's look at some other places where we find chemical energy. I've got my usual cup of coffee here, and I've got some sugar. Now, sugar is a chemical, a carbohydrate, and sugar contains chemical energy. And when I add sugar to my coffee and then drink the coffee with the sugar in, the sugar goes into my body and it provides me with energy. So sugar is an example of chemical energy. I've got here an empty bottle of Sprite. And if I look on the label of the empty bottle of Sprite, it says nutrition facts, energy 48 kilocalories. So Sprite has got chemical energy in it. And if I look at the mobile phone, here's my mobile phone, and in the back of the mobile phone is a battery, and the battery is stored chemical energy. And when the chemicals in the battery interact, they create electricity which runs my mobile phone. So chemical energy is all around us. Let's have a look at chemical energy in action. And my helper here is going to set off the firework. And in a moment, we're going to look at food, because food is chemical energy. And that's why when we eat food, it allows us to run a marathon, because the chemical energy in the food can be turned in our body muscles, can be turned into kinetic energy. So food. But before we go and look at the food, let's set off a firework. The chemicals that are inside a firework, the chemical energy is in there, and when you light the firework, the chemicals react together and generate a lot of heat and light, as we shall see now. So when we are putting diesel fuel into the motor car, what we're doing is putting chemical energy into the car. The diesel fuel is a chemical. And when it burns in the engine, we get energy, heat energy out, which produces kinetic energy in the car. So we're putting chemical energy into the tank of this Hilux. Why we're here is because today Bhutan, the Tourism Corporate Council of Bhutan, has decided to celebrate World Tourism Day by showcasing all the different sorts of food that you can get all over Bhutan. Some delicious food. I want to show you that chemical energy is not boring. Chemical energy is tasty. Chemical energy is delicious to eat. Chemical energy is food, or food is chemical energy. And so, if I were to give you a pill labeled chemical energy, it might be a bit terrible. But we can actually, through our cooking, make chemical energy very, very delicious. So here is examples of chemical energy, all food which comes from the Keng region of Bhutan. So when you think of chemical energy, you think of food, because without the energy in the food, our bodies could not survive. We will die. Chemical energy is fun. Chemical energy is delicious. Chemical energy is tasty, and chemical energy is necessary for our bodies to function. The chemical energy in the food allows us to run up mountains. It allows us to go on bicycle rides. It allows us to take part in marathons. It keeps all our bodily functions working. Without the chemical energy that we have in food, we would all die quite quickly. So enjoy all the different foods that you can find across the Kingdom of Bhutan. Another form or type of energy is electricity. And this is a really useful form of energy because we can send electrical energy along wires. And here we are at Simtoka looking at the great big transformer station where the electricity which comes from various hydropower stations in Bhutan is all brought for distribution to Thimphu and the whole of the valley around. So electrical energy, very, very useful. We'll say a little more in a moment. Hello. Well, now, I'd like to introduce to you Mr. Tsencho, who is the Managing Director of Kunsel, who's just arrived here in the Kunsel office in a new electric car. And Tsencho will tell you a little about why he's chosen an electric car.
Nice to see you here in our compound. The electric car probably was brought to Bhutan about a year ago. After seeing this car, Kunsel actually decided to buy one. The reason being that we do a lot of running around here in Thimphu. Our reporters are always on the road, our marketing people are always on the road, and driving in a bigger car we felt was firstly not very advisable here now in Thimphu because of the number of cars on the road here. This car actually makes it possible for people to even park in a very small congested area. Secondly, it does not have an engine like the other cars. So it is fully powered by electricity, and as such it does not use any fuel. That means we are actually saving, we are not polluting the environment. I think the biggest plus point for this car is that we are not polluting the environment. And we at Kunsel, we're very much conscious about our environment. I think our constitution also makes a mention of saving the environment. So we as a responsible organization, I think we need to be also very much in tune with our national policies. I personally drive this car, especially when I go for meetings, whenever this car is available. Often this car is not available during the office hours because the reporters keep going out. So whenever I get an opportunity, I always try to use this car because it firstly is saves the environment because it has no pollution. Secondly, it also saves my company a lot of money, which otherwise we'll be using on putting fuel in our other cars. So I would actually advise people to probably go for such cars so that the environment here in Bhutan can be saved. We can save something for our future generations. And I think this is something that we, as Bhutanese, we need to bear in mind.
So this is Kunsel's electric car, and as the Managing Director said, it doesn't use diesel, it doesn't use petrol, it uses electricity to power it. And in here, at the back, we've got batteries. And instead of putting diesel fuel or petrol in, all you have to do is plug it into any power point, an ordinary domestic power point. And this puts electrical energy back into the batteries, which can be used to drive the car for about 100 kilometers. So electrical energy is very, very useful. You can use it for heating your water, for washing, or for making a cup of tea. You can use it for cooking your rice in a rice cooker. You can use it with electric radiators for heating a room. And of course, most useful of all, you can use it to light an electric light bulb so that you can read and work in hours of darkness. Electrical energy, so useful. And you'll remember one of the big points about electrical energy, you can send it down wires. So the electric car uses batteries, non-polluting and very, very good for use in a town such as Thimphu or Phun Soling or Monga, Wangdi Phodrang. Very good indeed. Everybody should use one. And this car that I'm sitting on is a very special car. This is the very first one of its sort to come into Bhutan. And this car is special because it works with electricity and with petrol. There's a petrol engine in the front, but there are also batteries and an electric motor. It uses two sorts of energy, chemical energy in the petrol, electrical energy in the batteries. Now, this means it is very, very environmentally friendly. When I'm driving in the town, I can use the electricity. No fumes come out, no exhaust fumes. When I'm going up steep hills or for very long journeys, then I can use the petrol engine. But there's another very good thing about this too. Usually, when I apply the brakes in a car, the wheels get hot. The kinetic energy of the car is turned into heat energy. And it's all wasted. It just goes to heat up the air all around us. Well, with this car, it's much cleverer. Because if I want to slow down, the kinetic energy of the car turns a generator which recharges the batteries. So this means very little wasted energy. Now, this sort of car, working with two different sorts of energy, this is called a hybrid car. And this is the car of the future, working with chemical energy and electrical energy, with petrol and with electricity. The hybrid car. Look out for it. Some more will be coming into Bhutan. Yeah, okay, now I want to talk a bit about heat energy and try to answer the question, what is heat energy? Well, we're all familiar with things that are hot, we're familiar with things that are cold. We know when we're feeling hot, we like to wash our face in hot water. So what actually is heat energy? Well, it's actually quite simple, and I've come here to Thimphu Primary School to try and explain. Because heat energy is kinetic energy. But it's not the sort of kinetic energy of a truck moving along the expressway. It's a bit different. Heat energy is the kinetic energy of molecules. You've learnt about molecules. All substances are made of molecules. Heat energy is the kinetic energy of molecules. Now, I'm here at Thimphu Primary School because molecules behave very much like primary school children. Molecules, just like primary school children, have got lots of energy and they rush around all over the place in a random way. Now, what does random mean? Random means they're running around in all directions, totally uncontrolled, and that's what random movement means. So in a minute, I'm going to get the primary school children at Thimphu Primary School to act molecules. Go! Hotter! Hotter! Stop! Right. Now you notice the line here. This is just like the surface of, for example, a bucket of water. The molecules of water don't come out. They stay in the bucket of water. But if I heat up the water even more, some of the molecules have got enough energy to escape out. And the water molecules begin to fill the whole of this area. And that is called boiling, when the water turns to steam. Boiling! So heat energy is the kinetic energy of random movement of the molecules in a material. The kinetic energy of random movement. Now, if I make something hotter, what I'm actually doing is making the molecules in the object, I'm making the molecules move more quickly. I'm giving them more random kinetic energy. And if I make them hotter still, they're moving even quicker. And this is what causes something to change from being a solid to a liquid to a gas. When you have a solid, the molecules all stay in the same place, but they jiggle around. Add heat energy, and the molecules start to move around. They don't stay in the same place, they start to move around with random movement. And that's why a liquid will flow. And then if you make them hotter still, they move around quicker. And if you give them enough heat energy, they get enough energy to escape out into the air. And that's what happens when water boils. The molecules have enough random kinetic energy to start rushing around out of the liquid and into the air, and we see the water molecules then all over as steam. If you crash your car into a big rock, all the directed kinetic energy of the molecules in the metal of your car is suddenly, when you impact the rock, it's turned into random movement of the molecules, and your car gets hot. When you apply the brakes in your car, the brakes get hot. The directed kinetic energy of the molecules is turned into random kinetic energy of the molecules in the brakes, and the brakes get hot and take away energy from your motor car. So remember, molecules are like primary school children. They've got lots of energy and they rush around all over the place. When I heat them up, they rush around more quickly. Heat them up enough and they can escape from the surface, like with boiling water. And that's different from the kinetic energy of throwing a brick or a car moving along. Because when I throw a brick or when a car moves along the road, all the molecules have got kinetic energy in the same direction. But with heat energy, it's random directions.
Next, you will see and hear the most powerful nuclear weapon ever detonated in the world. The Emperor bomb is the Western name for the Russian hydrogen bomb that was codenamed Ivan by its developers. It was the largest, most powerful nuclear weapon ever detonated in the world. Next, the Emperor bomb and other bombs less powerful that will follow it.
Well, that was quite an explosion. That was the explosion of a nuclear bomb, where nuclear energy is converted into heat and light and a great deal of sound. Now, nuclear energy is a very, very important form of energy because it is the most powerful form of energy available to us here on Earth. Nuclear energy comes from interactions of the nucleuses of atoms. And we all know about atom bombs and hydrogen bombs. And you know, the sun is one very, very, very big nuclear bomb. That's where the heat and the light we get from the sun comes from nuclear, a continuous nuclear explosion in the sun. So the sun is one great big nuclear bomb. Now, nuclear energy, uncontrolled in an explosion, can be very, very, very damaging. On the other hand, nuclear energy, controlled, can be used in a nuclear power station to generate electricity. Nuclear energy coming from interactions of the nucleuses of atoms, a great source of power here on Earth, and the source of all the energy which comes to us from the sun. Just to go back about what we've said in this program, we've talked about energy, and we've seen that energy in a way is a little bit like money. And we've talked about the types of energy, and we've seen that types of energy are a little bit like the different currencies, the US dollar, the Bhutanese Ngultrum. And we've talked a little about kinetic energy, which is energy of movement. We've talked a little about gravitational potential energy, gaining gravitational potential energy as we go up in a lift. And we've talked about electrical energy. We've seen it's very useful. We've seen electrical energy in the latest development, an electric car and a hybrid car. And we've talked about chemical energy, the energy you get when two chemicals interact with each other. Radiant energy comes from the sun as electromagnetic waves. We've talked about nuclear energy, this most powerful energy that we get when nucleuses of atoms produce the energy. And that's the most powerful source of energy we know. Controlled, as in a nuclear power station, it's very, very useful. In an uncontrolled explosion, a nuclear explosion, 3 or 4 bombs would destroy Bhutan. And last of all, we visited Thimphu Primary School to see that heat energy is in fact the random kinetic energy of molecules. And thanks to Thimphu Primary School children for behaving like molecules. Heat energy, very common. We all have a very good understanding of heat energy. So, energy and the types of energy. Now, one really important thing that I'm going to talk about in the next program is how we can turn one sort of energy into another sort of energy, the conversion of energy. And so until then, let's remember the nuclear bomb and give thanks that Bhutan has never ever, and nor I hope will it ever, experience a nuclear explosion. Energy. We need it to live. Everything needs it to live.